Well, it turns out erosion is not the only force at work making canyons. It's said if erosion were the only force shaping the Earth's surface, then our landscape would be as smooth as a billiard ball. Erosion, with gravity's help, works to smooth the land. It works especially hard on high places such as mountains. Eroded material is spread on surrounding countryside until gradually everything is level. But an opposing force works on the land too, called uplift. Uplift is the process by which areas of the Earth's crust rise over vast periods of time. The causes of uplift are varied, but they're all part of a process called plate tectonics. The theory of plate tectonics tells us the Earth's crust is made up of a series of great rocky plates that constantly move in relation to each other. Uplift, which is caused by this tectonic movement, is the force that helps create great mountain ranges, and it helps create spectacular canyons too. But how can uplift, the raising of a section of the Earth, create a canyon where the Earth has been dug down? Well, let's consider what we call the case of the three connected canyons: the Grand Canyon, Zion Canyon, and Bryce Canyon. All are within 150 miles of one another, but each is a separate, distinct canyon. At Bryce, most of the rock is so soft you can scrape it away with a pocket knife. Thus, the rate of erosion is high. There is no river cutting into the Earth at Bryce, but rain, snow, and wind have sculptured these soft rock walls into a fantastic display of shapes. Horizontal layers on the hoodoos and throughout the canyon tell us this material was deposited here as sediments in an ancient sea. The oldest layers are at the bottom, and the youngest at the top. It is the age of the rocks that give us the important clue to the canyon connection. Remember, in forming sedimentary rock, particles of eroded rock and soil settle layer upon layer. Over millions of years, these sediments harden. The layer at the bottom will be the oldest, the layer at the top, the youngest. But the oldest of the rocks at the bottom of Bryce Canyon are from the same geological age as the very top layers of Zion Canyon 50 miles away. These massive sandstone rock walls at Zion were formed from great sand dunes 150 million years ago. However, at the bottom of Zion Canyon, the oldest layers are sedimentary rocks deposited 50 million years before that. This bottom layer of sedimentary rocks, formed 200 million years ago, shows up in another place to give us a final clue to the connected canyon story. In the north rim of the Grand Canyon, 100 miles away, we find that layer of sedimentary rock. What does this rock layer connection between the three canyons mean? It suggests the whole area is uplifted at an angle, with the Grand Canyon lifted most. Our group of spectacular canyons lie on the Colorado Plateau, a large elevated area of land covering parts of 4 southwestern states. The Colorado Plateau has been uplifted because the Earth's crust is thin here and is getting heated below by magma, hot liquid rock from deep within the Earth. The magma has caused the crust to expand, resulting in the bulge upwards. As the rock layers slowly rise, rivers and other erosive forces cut down into them. If we draw a profile of the Earth's crust in the area of the canyons, we can get a better understanding of what appears to be happening. Bryce Canyon is here. Zion is here. And the Grand Canyon is here. Their depth has been exaggerated in this illustration, but you can see that the rock layers have been tilted and uplifted by gigantic pressures within the Earth's crust. Thus, the rocks at Bryce are the youngest. At Zion, those young layers have mostly been eroded away. Here, rock layers are the next oldest. At the Grand Canyon, all of these earlier layers have been eroded away and older rock layers are exposed. By being the highest, the rock around the Grand Canyon has eroded the most. When this area was uplifted, the stress created a fracture or fault in the Earth's crust. The Grand Canyon follows this fault. In addition, the Colorado River also follows the fault. This large river has been a major erosive force, as we can see by the size of the canyon it has helped to create.